Hello everyone, I'm Sang Lee from South Korea, and it's a great pleasure to introduce the series of my work about one of the most heavily and intensively studied topic of community structures in network science. I guess everyone here knows about this karate club, and there are multiple review papers on this meso-scale structure with the heavily connected component. However, I would like to bring some attention to a particular aspect about this community detection. If you just learn about this community structure from, for example, textbook and review papers, you may think that this is the problem of detecting the community structure. So for instance, if you detect a community from this particular example, you will get this result. But in fact, that's not always true, because there are stochastic algorithms to detect this community. And by definition, when you use the stochastic algorithm, in principle, you can get this different result for each realization of the community detection. So it's literally an inconsistent result, and you may consider this inconsistency is not a very good thing, or some kind of a limitation or error in this stochastic community detection algorithm. But here's our first key question. Is it always bad or evil thing to have this kind of inconsistent result from stochastic algorithms? It turns out that we can actually use these different results for each realization as features instead of defects to investigate the network structure. So we can actually turn this seemingly dark side into the light side. If you look at this co-occurrence matrix represent the fraction of node pairs belong to the same community. So it's either 1 or 0 for very clearly cut community structure. For example, this part or this part. They always belong together for every realization. In contrast, this particular 3 nodes have intermediate values, meaning that they sometimes belong to the left side and sometimes belong to the right side. So if we quantify this kind of inconsistency in community detection for each node level, we can actually detect this bridge structure. We introduce this community inconsistency, or COI, and it essentially measures how inconsistently is the node clustered with the other node, or it represents the functional flexibility or bridge node somewhere between this tightly bound group and this tightly bound group, and it mediates between these two groups, which would be of course very important in various types of real world networks. So to systematically study the properties of this community inconsistency, we analyzed some model network system and some real world network, and we found some interesting examples like outsider node in Zakari's karate club network, where he has very large values of community inconsistency but very small number of friends. In this Star Wars character network, we actually identified Luke Skywalker, the main protagonist of the entire series, has large values of community inconsistency, and of course that doesn't mean that he's an outsider of this series, because he's the main character, so he naturally interacts with lots of friends and enemy from light side to the dark side. So we name him as a multiplayer. Recently we brush up on this old measure of inconsistency and develop a new series of inconsistency measure in both entire network level and individual node level. And finally, we would like to give some criterion to choose the appropriate values of a community resolution, usually denoted by this gamma value in the famous modularized formula. And the large values of gamma enables us to discover the finer grained community structure. And the biggest problem was that there is no criterion to choose which values of gamma would be the most appropriate for each system. And by applying this inconsistency measure, we find this kind of deep structure here. Here, the valley or deep structure means that they are actually consistent in this range of gamma, meaning that the community found in this range of gamma can be more reliable compared to the other part of the resolution parameter, we believe. So that is our final message and perhaps the practicality of our work. So here's the summary. And our main message would be the inconsistency is not necessarily a bad thing. So in individual node level, we can actually identify outsiders and multiplayers, but by using the system-wide level inconsistency measure, we can actually use this to indicate the most meaningful communities or most meaningful scales of communities in a wide spectrum of the community resolution parameter. For details, of course, you can always check our real poster in one-page PDF format on the conference website, and hopefully we finalize the second paper and let it out to the world very soon. Thank you for watching.